Class, in this video we're going to continue our series on systems of equations, and we want to look at a second aspect of the elimination method, or at least a part two of the elimination method. Now I'm going to start off with two equations here, and you'll notice that when you consider each equation, we have both have an x, both have a y, we have our integer to the right side of the equal sign, so they're written in a very similar or consistent format. 2 and a 4, those don't cancel or eliminate when I add them together. And a 3 and a negative 1 outside of this x, neither do those cancel if I were to just add or subtract the equations. So instead of multiplying by a negative, in this case, look at this, I'm going to be multiplying the bottom equation by a positive 3. Now look what happens when I do that. To the right, I just carry over 3x plus 2y equals 12. But once I distribute the 3, I'm going to distribute this 3 throughout, I'm going to get negative 3x plus 12y equals 30. And now I can combine them. And so when I add them up, 3x minus 3x cancels. It goes bye-bye. 2 plus 12 equals 14y. 12 plus 30 equals 42. Divide both sides by 14 and you get x equals 3. Now, it's the same thing we've been doing. That was the only thing new. Multiplying, in this case, the bottom equation by a positive integer greater than 1. All right, so to be able to get these coefficients offsetting one another. That was the whole goal. And now once I've done that, everything else is the same. If y is equal to 3, then I substitute 3 in for y. Here I'm using the first equation, this equation right there. And once I substitute and work through the math, I get x equals 2. So my solution, these two equations are lines. They can both be written in the form of y equals mx plus b. When I graph them, they intersect one another at a point located at 2 in the x and 3 in the y. And then as I've been showing you, we can check this solution. I used the first equation. I plugged 2 in for x. 3 in for y, solved accordingly, and yes, 6 plus 6 does in fact equal 12. All right, with all of that said, let's work through another example. Kind of gives you an overview of what we are doing here. So let's start with this first example over here to the left. I can see that I have a 5 and a 3. Well, those don't cancel. And I have a 2, and we know there's a 1 right there. So those don't cancel. What am I going to do? Well, I'm going to take the smaller. I've decided, I've made a decision. I want to eliminate the x variable. Now, why would I eliminate the x? Because of that 1 that is right there. Because now all I have to do is multiply the bottom equation by a negative 2. Now, why a negative? Because this 2x is actually a positive. And so by getting this x to become a negative 2x, I will be able to eliminate the x variable. So let's write down our first equation because I'm not changing it at all. And then I'm going to distribute the negative 2 throughout, and that's going to give me a negative 2x minus 6y is equal to a positive 10. All right, let me change colors. Those are going to cancel when I add these two linear equations. This will give me a negative y equals a negative 3. Divide everything by a negative 1, and I get y is equal to 3. So that's the hard part. Now we substitute. I'm going to say x plus 3 times 3. If y equals 3, I'm just going to replace this y with 3 right there equals negative 5. So that's x plus 9 equals negative 5, or x equals negative 14. So my solution is going to be negative 14 and 3. Well, as usual, there's a lot of repetition to this. Let's figure out if we're correct. Let's put negative 14 in for x plus 3. Now that 3 is this 3. I'm going to substitute the 3 in for y and ask, does that equal negative 5? Well, negative 14 plus 9 equals negative 5. Yes, it does. It does, in fact, equal negative 5. And so I have answered this problem correctly. All right, now pause the video and try the practice problem off to the right. All right, guys, well, hopefully you have solved the practice problem. I noticed that the bottom one is the easiest one to manipulate, so I want to multiply it by a -7. All right, a -7. I'm going to distribute that -7 throughout. It's going to give me a -7x minus 14y is equal to a +7. The bottom equation, I'm just going to write it underneath. I didn't change it at all. I'm just going to write it underneath. When I add, notice, -7x plus 7x, that cancels. It takes you back to 0. -14 minus 3 is a -17y. 7 plus 10 is 17. Y is equal to -1. All right, let's choose one of our equations. We'll just use the top one. X plus 2 times -1 equals -1. And so that's going to be x minus 2 equals -1, or x equals 1, because I'm going to add 2 to both sides. So my solution is going to be 1 and -1. All right, let's check that and make sure it's right. We're going to let's just use the bottom equation. Take advantage of a little space over here. 7 times 1 minus 3 times -1. Does that equal 10? Well, that's 7 plus 3, and yes, it does equal 10. So I have answered that problem correctly. All right, one more example and then one more practice problem in this video. This one is a slightly different. Notice that when I look at these two equations, I'm going to have to multiply both of them. All right, now you've got to stop and think about it. All my signs are positive. All my integers, or the coefficient here, are different. So I'm going to have to, at this point, decide which variable do I want to eliminate. And you can choose to eliminate x, or you can choose to eliminate y. I'm going to choose to eliminate y because the two numbers are smaller. Now watch this. I'm going to start with the top equation, and I need this 2 and this 3 to be the same number, just with opposite signs. So in this case, if I multiply them together, I get 6. So I need one of them to be a +6, the other to be a -6. So why don't we just do this? I'm going to multiply this by a +3. That means I'm going to distribute this 3 throughout. Well, let's go ahead and do this. So that's going to be 18x plus 6y is equal to 3 times 14. What is that? Is that 72? Hopefully you said, no, that's not 72. At least I hope that's what you said. All right, so what is 3 times 14? That's going to be 42. 3 times 10 is 30. 3 times 4 is 12. And you add 30 and 12 and get 42. Okay, so now that we've solved that major math dilemma, that's my new equation. But now, let me change colors here again. What about this bottom equation? Again, I need this to become a -6y because that's what it's going to take. I need this right there. I need that to go to 0. How do I do that? I'm going to multiply by this 2, but I'm going to make it negative. So watch what happens when I distribute. That's going to be -8x minus 6y is equal to -2. And now I can add these. Those cancel. 18x minus 8x, that's going to give me 10x. 42 minus 2 is 40. I divide everything by 10, and you get x is equal to 4. All right, so now the hard part is over. Let's pick one of these equations and substitute the 4 in for x. So we can have one equation, one unknown. That's going to be 3y. That's a 16, so that's going to be a -15 on this side. I'm going to subtract 16 from both sides, so that gives me y is equal to -5. Now again, I'm going quick on some of these because we've been doing that stuff for a while now. I'm hoping it looks very, very familiar to you and you're feeling comfortable with it. So my solution, where these two lines are going to intersect, is at a point located at 4 in the x and -5 in the y. Let's check our work real quick. Let's just use the bottom equation. 4 times 4 plus 3 times -5. Does that equal 1? That's the question. Well, that's 16 minus 15, and yes, in fact, it does equal 1. So that is the correct solution. Go ahead and pause the video. Try the practice problem. All right, here we are on this practice problem. When I look at this, I'm going to have to multiply top and bottom by something, but at least in this case, I have different signs. I'm going to go for the y again. So why don't we do this? Let's multiply the bottom equation by 4 and the top equation by 3. I don't have to change my sign because the signs are already different. So the top equation is going to change to 18x minus 12y is equal to 18. Bottom equation goes to 20x plus 12y is equal to negative 16. All right, change colors. Those are going to cancel, and I'm left with 2x equals 2 or x equals 1. Pick one of the equations. I'll do the bottom one. 5 times 1 plus 3y is equal to negative 4. So that's going to be 3y is equal to negative 9 or y is equal to negative 3. So my solution is 1 and negative 3. Let's check our work. Use the top equation. Negative 6 times 1 minus 4 times negative 3. And does that equal 6? That's negative 6 plus 12. Yes, it does in fact equal 6. So I have the correct answer. All right, elimination takes some practice. Don't give up on it. Go back and watch this video again and bring your questions to class or send them to me by email. Thanks.